Now is an example of YouTube using MPEG- and the adaptive HTTP streaming technology. In this example, you can see that there are 8 video resolutions that YouTube uses. Here we have the 144p, the 240p, the 360p, the 480p, the 720p, the 1080p, the 1440p, and the highest resolution, which is the 2160p. What is this p? This is showing the number of pixels, as you can see right here. The pixel structure of an image has a width. For the 144 case, the 144p case, you can see that it is a 256 by 144 pixel image. And the 144 is what becomes the reference for the 144p resolution. So as you can see, the height number having a p next to it is what defines the image resolution. That is why these numbers are listed such that the number following the multiplying sign with a p is what is the resolution way over there. What are the differences of these rates? In reference to this rate, which is the lowest rate of the video resolution, then the other ones go up like this, in which the 240p is 1.6 times of a higher level. Then the 640 by 360 image is about 2.5 times of a higher resolution mechanism. And you can see the numbers go down here, become larger and larger as the resolution is at a higher level compared to the 144p video that is here. The internet uses HTTP streaming over TCP most commonly for video streaming, as we already talked about. And that is used in YouTube. However, other very popular techniques such as Netflix and Hulu also use it as well. Types of HTTP video streaming. There is the regular HTTP streaming, which completely downloads the video to the client device. Then there is progressive, which is progressively going to download the video at a fixed quality. Then there's the adaptive one. This is the adaptive streaming over HTTP, where it is a combination of adaptive video quality, adaptive video rates, control and progressive downloading techniques are all used together. Typical techniques that will support this are the MPEG- in which YouTube is using. So you can think of this right here as what is being used by YouTube. Progressive downloading advantages. A mobile device may not be able to store the entire video due to limited memory space. In this case, progressively downloading is nice because if you do not have enough space, this will prevent you from actually viewing the video if it is required to have it fully downloaded. However, progressive download is a technique in which you can download and the downloading amount may be up to about 2 seconds, 10 seconds, maybe even 30 seconds worth of it, and that will be in the buffer and displayed. So therefore, the parts that have already been viewed can be erased. So therefore, you do not need to save the entire file. And that is a real advantage for devices that have limited memory. Even if you have a lot of memory, if the video file is very large, then still you face the same problem, and this works as a wonderful solution. In addition, many users do not watch an entire video. For example, in YouTube and other services, a common factor that is analyzed and discovered is that many people only watch about 20% of the entire video. So if you download the entire video and view it, then 80% that you're not going to view was a total waste in your personal data usage and also the internet bandwidth consumption. So therefore, progressive download is going to provide you with this benefit. You're going to save your personal data and you're going to save usage of the internet bandwidth. These techniques make MPEG- so attractive, and that is why YouTube is using it. Here is one example of a YouTube-based MPEG- video service, and please note that there are periods in which changes are made. In addition, please note that in the video and audio, there are multiple quality levels. Of course, the ones that have the higher data rate are the higher resolutions, as in terms of video and audio. Looking into the details, we start at point 1. This is the same reference point of video and audio, as you see right here. Then, as you go and progress, you will see that in this example, due to conditions that are changing in the network, and the network conditions are getting worse, the throughput is being reduced, more delay is being experienced, packet errors are being experienced, then we drop to a lower data rate. We don't drop all the way to 1, but we stay at that level, which is next to the 5 megabits per second, which is the 2 megabits per second. And here you can see that we only drop the video quality, where the audio quality is maintained. This is because the video quality drop results in a larger saving. So we're going to gradually degrade the overall resolution and performance of this service. Then we stay at this level, and you'll see that the next step, due to degrading quality conditions, that as we drop from 2 megabits per second down to trick mode, you'll see the same thing in which we have 128 kilobits per second drop down to the lower audio mode. Then you see that at trick mode that we go back to a certain position. This is where you put your finger on the video scroll bar and move it back to a certain position. What happens over here is that that effect will be shown in both the video and the audio. Because if you pull back your video to a certain position, if you do a rewind to a certain position, where you're going to do a review back at a former video segment that you've already viewed, well, when you do that, of course, the video and the audio needs to be matched at that current point. And that is what you're seeing right here. It is based upon the trick mode. Then, starting back at point 4, this is where we're going to start. And then, as the network condition improves, we go to a higher audio quality and a video quality together. And that is the way that YouTube MPEG- is controlling it. Over here, you see that what is being provided is only with 3 video resolutions and a trick mode. But YouTube videos can be with more resolutions included inside. For example, we did a couple of pages earlier, it had more levels, up to 8 levels that were used. And that is where our video is at stage 5, and it continues on into period 2. MPEG- specifications based upon ISO IEC 23009-1. The MPEG- standard only define the MPD and the segment formats. The MPD is the media presentation description. The MPD delivery format of media encoding that will include the video segments, adaptive downloading, video playing control are determined by the application on the client device. The HTTP server, here, the MPD and the video and audio data segments are stored in the server and maintained and controlled there. Playing on a Dash client is based on step 1, where the Dash client requests for MPD from the server to be sent. Once again, this is a pull mechanism, so the client needs to request for it to be delivered from the server. The typical pull mechanism. The MPD is delivered to the client using HTTP, email, thumb drive, broadcast, or some other mechanism. The client parses the MPD, and then the client MPEG- application reads its information. The program timing, media content availability, media types, resolution, minimum and maximum bandwidth, available multimedia resolution types, and so much more information can be read. The client selects the appropriate encoded alternative and starts streaming the content by fetching segments using HTTP GET requests. This is exactly what? The pull mechanism, and it's going into action. Appropriate buffering is used to compensate for network throughput variations. The client continues to fetch subsequent segments and also monitors the network bandwidth fluctuations. The client adapts to the available bandwidth by fetching segments with lower or higher bit rates to maintain an adequate buffer. On the HTTP server side, there are segments and fragments. In addition, there's the MPD, the Media Presentation Description. And through MPD delivery, on the Dash client side, you can see that there is a parser for the MPD. There's a segment parser for the segment video streaming data. There is a media player unit. Also, down here, there is an HTTP client. Here in this example, it is based on HTTP 1.1. It could be based on 2.0. And then there is a control heuristics engine. This is all in the Dash client and working together such that the MPEG Dash video can be played on your device with help from the server. This is exactly what YouTube MPEG Dash uses.